Well, welcome everyone to another in-depth with OpenTEAM. OpenTEAM is the open technology ecosystem for ag management, the project of Wolf's Neck Center for Agriculture and the Environment. And our dynamic and growing community consists of over 40 some organizations and 200 individuals who are active every month in various working groups and OpenTEAM related meetings and activities. So this learning series is really to help build the knowledge base of the OpenTEAM community in a way that fosters coherence and collaboration. And each in-depth helps us to collaboratively evaluate new concepts and technologies in an effort that we can ask better questions and we can build better tools through sharing our work. So we seek to address common barriers rather than promote any specific solution. And in this pre-competitive space that we hold, we bring together public and private partners to achieve better outcomes and accelerate our level of innovation across boundaries. So today we have Samir Johal, who is the co-founder of AgStack Foundation, which was kind of birthed out of the Linux Foundation. So he's going to share more about that today with this community. And OpenTEAM has been involved in the last few months with the launch of it officially in May. And we're excited to continue to pursue ways that we can collaborate with the AgStack Foundation and docking some of our tools potentially and apps into the AgStack Foundation platform. So Samir, I'll turn it over to you. Thank you again for being here and joining our community.
My pleasure, Laura. Thank you for the introduction.
Yeah.
Can you all hear me okay? Yeah? Laura, can you hear me all right? Okay, good, good. All right, nice to meet everybody today, this morning. Good morning to everybody on the West Coast, and good day, good evening to everybody around the world. I know that we're all in a dispersed community, but it comes together through agriculture. So really excited about meeting all of you and building on old relationships and creating new ones. I was asked to provide some background information and an overview of AgStack, which I should do, but it would be great to also have any questions at the end. And Laura, what's our time frame like? That present for about 20-30 minutes, or is that the right idea?
Yeah, that sounds about right. And then we'll have 20 minutes plus for Q&A.
Okay, great, great. So let me begin with just a quick introduction to myself, my background, and then we'll jump right into AgStack. I have a few slides. I can share my screen and walk you through those to structure our conversation. So my quick background is, as many of you know already, I grew up in an ag family in northern India. And so I was born and raised in the Punjab area in northern India. Very similar climate to California. In fact, the word Punjab, for those that are interested, means the land of 5 rivers in Farsi. And so it's literally a canal-fed / very California-like temperate climate. And right at the base of the Himalayas, very much like the base of the Sierra Nevada range. So I think very similar kind of feel to it. The people culture is also similar. Anyway, very proud of that heritage, but I came to the US when I was a teenager, did my undergraduate and graduate work in computer science, and then I've been in the tech field for the last 25 years. The first, let's say, roughly dozen years of that were really pure tech. I started off in semiconductors, did work in financial services, some work in medical devices, some in consumer finance. So really a pretty broad horizontal view of tech with the focus of data analytics, was not called machine learning, but some similar to those kinds of concepts, Bayesian learning, machine learning, and really saw the birth of the internet, the death and the rebirth, and it was really great to be part of that journey. The last dozen years of that journey has been really focused on agri ecosystems. It's a longer conversation how I got into that, but really it was about being motivated by my own background and the fact that agriculture ecosystems face a very stiff and formidable environmental as well as geopolitical as well as just human challenge, and there needs to be much more, and we're all part of that as well to address that. So that's why I got into it. I spent about half a dozen years leading a bioenergy company with R&D in California and actually operations back in rural India. So I've done a bunch of work in rural India, working with tens of thousands of farmers in the energy space. And then after I exited from there, I started AgriLogics, which is a for-profit startup that grew and scaled and is across several continents now in terms of back-end analytics around water. So that's my quick background. About a year and a half ago, I took a lot of the pain that I felt in terms of not having ubiquitous infrastructure and data and easy access to that, our team felt at AgriLogics and said, we really need to create a open and public usage of this. And while a lot of data sets are free and public, they're not easy to use. And so AgStack was born. AgStack is a project of the Linux Foundation. So while I was one of a few people to sort of bring this to AgStack, to the Linux Foundation and launch it, it really is a project within the foundational network and foundational legal framework of the Linux Foundation. And it is the only project the Linux Foundation has taken on in food and ag. They have done, or rather we have done, I should say, I'm part of the Linux Foundation, other projects in energy, for example, in the automotive sector, in media. So, the last 30 years have really seen an explosion of open source technologies in the tech sector. And the Linux Foundation is very unique in that it has become really a hub where these ideas have become easy to proliferate, and the governance structures have matured enough to provide that kind of governance and convening power that even often very competitive, fiercely competitive tech companies collaborate on, pre-competitive common infrastructure so that they can accelerate their own products, their own journeys, and create interoperability. And those are all themes which I know resonate with all of you. So that's a quick context behind my own background and how this whole came about. We just launched about a month and a half ago, so it's still in its baby stages, and we're delighted to be part of our members and partners like OpenTEAM to help us grow and to really connect to everybody here. So let me share my screen, if that's okay with you, Laura, and walk you through some slides. Can you see my slides?
Yes, we can.
Okay, great. As I mentioned to you, AgStack is a project of the Linux Foundation. We are an open source digital infrastructure. So really think of us like a road or a highway, where it's a community-owned, community-built, community-maintained piece of infrastructure, and then applications can be things like cars or trucks or bicycles or what have you that can use this road. And today everybody who wants to use an application has to build their own infrastructure. And so our goal and our idea is to create this digital infrastructure as a free and open infrastructure for people to both create applications and to consume applications in the ag and food space. I already mentioned a thing or two about the Linux Foundation. I'll repeat a few things just for context, is that it's really a unique perch to be part of the Linux Foundation. I'm a big fan of Linux. I use Linux for all of my work. If you think about cloud computing, just as a context, the entire world of cloud computing, all the tech companies, all the telecom companies, governments, infrastructure, the Department of Defense in the United States, all runs on Linux. And it's a free software, and it's ubiquitous. It's probably the most consequential piece of software ever written. And it's all free. So I think that's really should give us pause. We often think and dwell about these, trillion-dollar companies like Google and Microsoft and others who are doing some great work, but Actually, it's the free software. Even Microsoft's own cloud, Azure, is powered by Linux. So it's really a fantastic organization that has enabled this for the greater good, and we're really proud to be part of that. So, I mentioned this earlier on about the Linux Foundation. We have over 2,000 member institutions from over 40 countries, all, the telecom and tech companies, and over 250,000 developers by now, contributing to over 400 projects. And AgStack is one of those projects. So it's really a fantastic platform to be convening and collaborating with others who are like-minded. Some of the projects they've done is in automotive field, energy, etc., and now with agriculture. This is a slide that Jim Zemlin, the executive director of the Linux Foundation, talks about quite a bit. And I don't need to, really dwell on this for you guys, but from a Silicon Valley point of view, the reason why a lot of companies in Silicon Valley adopted open source as a core piece of their strategy. So if you look at Salesforce, for example, the acquisition of MuleSoft for almost 16 billion, this is all open source based. And the reason for that was that private companies found open source strategy to be an acceleration strategy. By not putting resources onto things that were not proprietary, they were able to reallocate those resources to things that were proprietary, and of course fund the common infrastructure in a collective way while competing on the proprietary side in a very fierce way. And by doing so, they raise the bar on innovation, they raise the bar on the speed and acceleration of creating these products. So projects in open source create products in proprietary land, which create profits for companies, which then funnel back into projects in open source. So that virtuous cycle of growth is what propels these open source companies to really, do a fantastic, adoption curve, proliferation of technology. And in agriculture, we need to learn and live by this. We need this desperately. The world of agriculture and ag tech in particular is, composed of warriors like all of you. The warriors need patterns and tools that have worked so that we're not inventing them every single time. And so that's really what this platform is all about. We've seen this now with AgStack as well in the early days, but private sectors choose to contribute because it gives them a competitive edge. And the top ranking companies by McKinsey, this is a slide from McKinsey, gives them a way to accelerate their new market opportunities, get them ability to collaborate with their peers, and ability to influence the market's direction. All these three things are extremely relevant for ag. Interestingly enough, this slide is not for ag, meaning this is a general thing for open source, the Linux Foundation. So I think I already showed you this. So AgStack is kind of envisioned, you can think of us as like a free and open source operating system, much like Linux, but just for food and ag. That's how we like to propose ourselves. So we're not applications. We're going to enable applications to be built and created and used, but we're not an application ourselves necessarily. Our goal and mission is to improve the agricultural efficiency, which includes sustainability, which includes environmental sustainability, because we feel that environment and food are interconnected. But it really is to improve the overall efficiency of the work that's in ag tech today through this reusable digital infrastructure. How are we different? First and foremost, the governance and experience that the Linux Foundation brings to AgStack is invaluable. As I was just speaking with somebody yesterday at a major fertilizer company out of Singapore, the open source is not new in agriculture or even in ag tech. There are plenty of very well-meaning and good open source projects that sometimes don't scale. And the reason they don't scale is because the governance and the structural aspects of what allows projects to invite stakeholders to convene, that governance needs maturity. And that's what the Linux Foundation has done over the years. So I think it's very different that way. Second, we're building software. We're not just building standards. Nothing wrong with building standards, documenting standards. I've worked in the tech industry around standards. It's very important. It's important in ag too. But we're not just doing that. We're actually commissioning software that will use those standards for tools and infrastructure such that people can actually use those standards and not have to necessarily even build them. The third is the tech inclusion. Some of our early members are not ag companies. So actually Hewlett-Packard, IBM, and many others are coming on board, from the tech sector. And I think that, is easier for us because a lot of them, in fact, all of them are members of the Linux Foundation already. So for us to reach out and include them in our membership, invite them to be members to us, both as paying members, but also as users, contributors. IBM is docking 9 different projects with, Linux Foundation. So it's really fantastic to see that tech inclusion. And it's quite broad. So while, folks here might be focused on soils, or other folks might be focused on controlled environment agriculture, other folks might be focused on equipment and automation. We're really looking at these as sub-projects with an underpinning of infrastructure that goes across all of them. This is a slide I made, which is sort of like a play on Jim's slide. And you guys are all open source, so I won't belabor you on why people should become a member of the open source. A lot of times when we have our first conversation, people say, well, maybe I'll just sit this one out and see how it goes, right? And that's sort of like sitting out an election. You want to be part of the process so that you can influence the outcome. And otherwise, you'll be a victim to the outcome. So I think influencing direction is a very important reason why we sort of try to educate companies to be members in our company. Here are some of the small projects we are starting off. We're really focusing on the kernel we call Ag 1.0, which is coming out in the end of the year in beta. But the sub projects that we're thinking about: crop nutrition and protection, soil and carbon, trading and supply chains, food safety, harvest management, equipment automation. Those are all sub projects that we're enabling this infrastructure for, and we'll be probably writing extensions for specific recipes and things like that for those areas. It's very much part of what the way we're thinking about this and the way we're structured. Going one layer deeper, think of us as a 4-part blob of things. There are 4 key pieces to AgStack, and they're color-coded. You'll see these colors later on as well. For the techies amongst you, we sit sort of in between the application and the cloud, or the application and the runtime environment. So we allow the application to benefit from all kinds of infrastructure while still being above the runtime environment. So we're not here to replace Google Cloud or Azure or your own computer. None of that. Just like Linux doesn't, right? You download Linux and you run it on your hardware. But we're not really technically an operating system. So we run on top of the cloud or your own hardware infrastructure, your own runtime environment, and below the application tier. And will most likely be bundled as part of the application when somebody sells the application, because the consumer won't know and doesn't need to know. And we like it that way, whether what they're buying from that proprietary company is open source completely or partially, right? The value, the benefit to the consumer, to the user is complete, is the whole thing. So that's how to think about us. And then there are 4 pieces: frameworks, models, data, and extensions. Frameworks are just software frameworks, like Django is a framework that allow us to take existing open source projects, frameworks that already exist, but then we can repurpose them, retool them, custom tailor them for specific uses in food and agriculture. Things like asynchronous message buses, or servers that host or backend databases for raster imagery, things like that. Because all these things are needed, but people shouldn't have to become experts in each area to be able to use them. And today they have to. Models is the second piece, where if you're building a pest model, or if you're building a model to look at how water goes through soil, or if you're looking at water, a model of how carbon is captured, by a particular plant or soil, or by, a cover crop or not cover crop or whatever. These models right now are either in academic papers, or you have to design and develop them yourself. But what happens is, particularly in the academic papers, the public models aren't easy to find. And whenever you do find them, you read a paper, then you have to codify that model into code, which is prone to errors. It's prone to all kinds of interpretations. Writing a math formula is not the same thing as having code. So what we're doing is docking a repo of all these models. We're starting with weather models, but then expanding them to pest and disease models and other types of models, soil models, for example, that can have a central hub, and people can both, contribute to that hub and use that in Apache 2.0 licensing structure, so that you have this ubiquitous, simple way to not only search for and find what you're looking for, but actually include it in your code with one line of code. One import statement, you're done. And that's really how, if you look at TAC, that's how they scale. That's how Google scales. They're not writing every piece. They're writing just the piece they need to write, and everything else is an import statement of some sort. So I think that's what we hope to achieve with models. We already have the benefit of having several national and international universities, ag universities, as members, and we have MOUs with them already. As an example, University of California, the National Institute of Agricultural Botany, and then a couple of universities in India to start with, and we're working out with Purdue and University of Florida, et cetera, to basically have all the researchers contribute their models in Python into this repo, and also be able to use them for their own research and their graduate students, et cetera. So models is going to be a big thing for docking this, and we encourage our community to work with us to dock their models. Again, this is all public data right now so far. Talking about data, that's the other piece of this. Models use weather data, for example, or soil data, or satellite data, or JPL's soil moisture data, or what have you. Today, if you want to use any of this data set, you have to start understanding the metadata, the structure framework, where are you going to download it, how are you going to use it. And some of these have S3 buckets and Google Cloud areas, but they're expensive. So it's cost prohibitive, and so people just don't know how to use them. And even if they do, sometimes not easy to use. So we're taking a single credential to access and building the tooling in the back, so that this data, you give it lat long or a polygon boundary, and you essentially get the data for free and quickly. And you also get the metadata. You're able to use parameters to essentially change the metrics, find out what the definitions are. And that's going to be very useful for, being able to access simple public and free data sets that are simple, public, and free, but not easy. They're not easy. So we're trying to make it easy on that data set. Then, of course, extensions and toolboxes are places where, we can have both topic specific as well as generic things like a natural language processing toolbox, or an ontology framework where, a whole bunch of ontological libraries can be docked, so that you essentially can use translation of ontologies between common words and scientific words, or identification of certain things on an image, or things like that. Tagged image libraries falls into that as well for machine learning. Those are the four big pieces. They're split up into 11 topics in our community, and we just had our bi-weekly meeting just this morning. Those of you interested in joining, in fact, several people here might be on that meeting. So that's how we're structured. What the project will not do as a mandate, we're not looking to create applications. We're not looking to compete. This is free and open software. We're not looking to charge anything to people using it. If you are not a member, you can still use it. Members just get the ability to steer the direction of the project, but anybody can use it for free. We will provide code samples, some sample apps, etc., to make it usable. Nobody wakes up looking for an operating system, right? People want applications. So particularly around hot topics like carbon, hot topics like water, hot topics like food safety, pest management, crop protection. Those things are all really important. Machine learning, artificial intelligence, robotics. So we'll provide sample code, but we're not building applications in AgStack. Some examples, this is just to drive home the point that the same infrastructure can be used by completely different applications, very much like a road can be used by different vehicles. And so while the road is being designed, it's not really being designed for a vehicle. It's being designed for vehicles. Similarly, when we're designing our digital infrastructure, we've got these, ideas in mind and applications in mind. So for example, taking the metaphor of the road, if you know the road is going to support, 10-ton trucks, then you want to make sure the road can support 10-ton trucks or whatever you're building. So having that idea is important, but we're not building trucks, we're building the road. So, that's just to drive home a point on that. And then I'll talk a little bit about our release. We've already started on the design phase of this, and design documents are underway. For folks who want to participate, I welcome you to join. Many of you do. And then, what's involved in this? We're going to focus on primitives. We're calling it our kernel or our egg. Call it whatever you like, but we're calling it Egg 1.0 right now. We're looking to deliver this in beta by the end of the year, but essentially the first set of work, which you see in the red, has already started on the user registries, asset registries, pub sub buses, Python models, global weather data. We talked about weather data extensively this morning. So I can talk about more about that, but those are some of the early things we're doing to get things primed for the rest of this year. We hope to have a beta release, alpha release sometime in October, and beta release before the end of the year. Here's a simple use case of that, where a user, this can be embedded within any application, but one user connects to another user through a channel to post a piece of information and get a response. And those primitives, that kernel, that workflow is what we're looking to perfect as a generic tool set, so that you can basically use that anywhere. You can have a farmer taking a photo of a pest as one use case, or you can have a processing plant talking about, we just shipped a whole bunch of hogs, or you can have an equipment shop talking about, getting an equipment in for repair. All these came from hundreds of discussions we've had with potential members and stakeholders around the globe. I mentioned 11 topics. There are 11 because some of them are A, B, C, D, but sort of 8 high-level topics that break into 11 atomic topics on our list. So these are those topics. We have each of them as a channel in our Slack. So if you want to join our Slack, you can go to slack.agstack.org, and you can basically join these topics and see the design docs going on. And that's really it, the high level. I have a quick example of this where I've shown this before. So like, for example, if you want to create an application for predicting powdery mildew, which uses an agronomic model and a plant disease model, we can basically take the weather data, and through just these 4 lines of code that you see on the top right, the model here is in the doc, which you don't have to build because it's already there. You can simply call that for a given lat long and a given time, and you get the integrated pest management model from UC and their output with 3 lines of code in a Jupyter notebook. You don't have to know where the weather came from. You have no, why should you know, right? You're not interested. You want to know what the, powdery mildew in grapes outcome is, or whatever your sort of weather disease model is that you want to predict. And because it's docked in AgStack, you just use it, bang, 3 lines of code, you're done. And you can embed that in an app, so you can say, okay, where my pest alerts are happening, this is an app that we built to sort of, you can tie some ontological practices to it. But the idea is that what might take otherwise, hundreds of thousands, if not millions of dollars, a team of a dozen people to do and take 6 months to create, one person can create in a week at most, maybe in a day. That's the goal. We're not there yet, but that's the goal, and that's very achievable. I believe it. I've seen it. I've lived it. I've built it for other areas. It's very achievable. In AgTech, we're all doing a lot of repeatable stuff, a lot of stupid stuff, which we don't really need to do. And we're doing it because there's no other alternative. People aren't stupid. We're very smart. Even the farmers, which people sometimes don't know about, extremely smart set of people. They have to be, otherwise they're out of business. So it's not the lack of smarts, it's the lack of tools. So that's what we're building. And with that, I'll conclude my talk and take questions.
Great, thank you so much, Samir. It's an important contribution, and I think you've articulated a lot of the concepts that are shared amongst the OpenTEAM community. I'd like to, I always have lots of questions, but I'm sure there are many from this group, so I want to leave the bulk of the time for all of you. Sophia, do you want to start off?
Yeah, so I have kind of a larger question on a little bit of background, and thanks for the presentation. This is really helpful to get the bigger picture. I work with a lot of remote sensing data and like pretty big data sets, using GIS, but also trying to integrate, some of these in-field data sets, say big soil samples. So I guess a question I have for you is, how do you see, I see that the value in this is integrating these larger global data sets with the site-specific data sets and aligned with models. So I guess I'm curious how you see all those working together, and maybe some of the larger data sets you've been looking at or you think might be able to integrate, and how all those might work together.
Yeah, great question. And I've spent the last 6 years also working with geospatial data, raster data, satellite data, soil data. Many people on this call probably have. So we're all data wranglers that way. Right? So I think that is a very important use case, that what you're talking about. As you well know, if you're trying to do it yourself, what are some of the sort of, for lack of a better word, I'll call donkey work, right, that we're doing? Sort of, no offense to donkeys. We used to have a lot of donkeys in our farm, so they're good animals. But the idea here is that, there's a lot of grunt work that we're doing. The grunt work can be as simple as learning, writing code to figure out how to use raster libraries in Python to, do masking for a given field boundary, and then take, how do I do, multiplication of the different layers of the different, spectra to create a vegetation index, and then how do I geospatially locate that and create, in my field, how do I map it? All those things, none of that is proprietary. Not one thing, okay? So the data sets are large, but all the code that you're writing to extract from that data set a mask for a given field boundary, right? The field boundary is the addressing index, if you will, okay? And everything, field boundary can be a lat long KML file or a lat long vector, but it's basically just a, indexing address. And using that indexing address, you're saying, I want NDVI, or I want leaf area index, or I want just the red, blue, and infrared bands of Landsat or Sentinel or whatever. And then you want to use the same mask or a subset of that, or a point within, or a centroid, to go get some soil information from a different repository. And then you may have a repository for your own private data, like a drone imagery, that you may want to go and get that. And all of it is, the private imagery I'll put aside for just a second, even though we're going to create tools for that. But let's just take the public data sets right now, right? You shouldn't have to do any of that work. So the data itself is hosted already, right, by the European Union or by NASA, and it's free. You have to have credentialed access to it, which you have to create and then remember. So if you had an AgStack credential, you should be able to give your field boundary and basically get a metadata of what kinds of things I can get. So we're thinking about any number of there are 26 or 27 known vegetation indices, MCARI and GNDVI, all this other stuff that researchers have created, right? And you can read about them, and we can have metadata about them as well, and a small dictionary. But essentially, if you say, I want NDVI, here's my field, from this time to this time, and here's my credential to access, bang, and give it to an AgStack API. That API then basically in the back does the work for you to essentially do all the parsing and cutting and provide that back in maybe a Django, GeoDjango, raster data set, or some sort of format that is compliant with current state-of-the-art software tools in a way that you can ingest it. And we're going to try to make that really, 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 really simple and easy without jumping into a no code. It's still going to be code because we're writing the infrastructure layer, and it's important that we start code first, not no code first. Applications need to be, no code first, but we're still going to be API based, code based first. But that grunt work is what we're looking to eliminate from your stack. You don't have to do any of that. Now, what you do with that, that's your proprietary stuff, right? Once you have it, it's in a pandas data frame or it's in some sort of data structure that you can manipulate. Well, then you're off to the races. But you don't have to do then all this other learning of how do I do cloud filtering on Sentinel dataset? I mean, how many of us have spent entire weeks doing just looking at how do I filter clouds? I mean, why are we redoing it every time, right? It just makes no sense. Everybody's doing it their own way. Why? That's the gap that we're looking to fill.
Thank you for that. Great answer. I align with so much of the things that you stated. There's so much busy grunt work that we all just are replicating over and over again in the same cycles. So I align with all of that. Thanks.
Glad to hear that.
I think we've got Jeff Herrick on deck. The question. Oh, and you're muted.
Thank you. This is Fant, and I'm muted. Thank you. I was watching that blue button. Yeah, thanks. This is fantastic. I'm equally excited. Maybe more so. I'm not sure, Sophia. We can decide later. But definitely, this is great. I do, though, want to make and ask if you thought about a huge distinction that I'm seeing that I'm not hearing you talk about. And that's the distinction between getting rid of the grunt work and a priori deciding what that default model is going to be. And I work extensively with the UNCCD, basically trying to do the same kind of thing to generate the indicators of desertification that all the parties have to report on. And I've then had, from the US side, had to look at that from our side. And actually, vegetation indices is a fantastic example of that, where the vegetation indice matters a lot. And a lot of people have no idea that it matters a lot. Now, sometimes it doesn't matter at all. I said, I mean, NDVI is ultimately NDVI, but if you're in a shrub or an annual environment, or what dates you're getting it from, and again, I'm just wondering, is there a way to get rid of the grunt work a priori? Absolutely. Cloud, yeah, no, I don't want to deal with clouds. I have no idea how to filter clouds anyway. I'm DGIs, and I know it's really complicated. So yeah, please do that for me, because I can't do it. But then the next step, can we put a step in there that basically says, do you care? Or, and what is the value of this decision? And what is the cost of making a bad decision? And of course, as we talked about on previous calls, we can put that in the context of accuracy versus precision. There's some ethics here too, and I won't go into those, but we're
it's a really good question. It's a really good question. I mean, this is a beer conversation, I guess. So one of those beer, coffee, pick your drink, right? So I think the short answer I'll give you, and then there's a much longer one which we can delve into if we have time, is that we have that model side of things where if you want to create a model that uses these indices to create, let's say, a decision tree of whether you should do something or not do something, or whether this is good or bad, or give a probability of how good or how bad it is, right? And I'm using a simple case. You can make it much more complex, but essentially a numeric or analytical model can be created and docked in the model repo, which has nothing to do necessarily with the data side, but the models can be married to the data access. So in fact, the example I showed you where I was calling a powdery mildew model, it's giving me the probability of a powdery mildew, and it's calling the data set automatically. I don't even know that it's calling the data set. And I can tell it not to call it and use my own data set as well. But in default mode, it calls the data set and gets me that because I don't really care. All I care is the model. I mean, you asked a very good question, said, why should we care, right? So the person who's doing the work on creating or consuming this application, which we're enabling, can build models in their own proprietary, but they can also use public models and they can put their model into the public domain for others to use. And researchers will do that at scale. Okay, because they're doing research, right? And the rest of us who are trying to use that research will adopt those, and the adoption metrics will show how good models are. So you can have, model use rates and those, just like ratings on Amazon or whatever, right? So essentially you can start to see different models get adopted as people organically start using these things. And that's separate from the data grunt work access, because that is all about then using this grunt work to drive the next layer of value. It's not all the way to the proprietary piece, but it's the next layer of value in saying, okay, I want to predict a pest, or I want to say, when will my tractor shaft fail on my tractor, right? Or I want to say, how, do I, what crop should I plant on this piece of soil? I give a lat long, I give a date, and I say, I'm a farmer in India, let's say, and I have a 2-acre piece of land. I'm trying to decide, should I plant tomatoes or should I plant beans or should I plant this? And that's a really important question because it has to do with not just supply and demand, it has to do with resource utilization, it has to do with all kinds of incentive programs. All those can be models that can interoperate and call each other. And we're not going to regulate those. We're actually going to unlock them to build on top of each other and organically let the community coalesce. Because if you look at how Python or other languages happened, that's how they happened. They happened because there was a curation and quality control separation from making it easy for people to use and dock what they were doing. It turns out human beings are massively collaborative. We all think of, money is zero sum, but actually we love collaborating. As long as we know that that will lead to us filling our stomachs and making sure we're secure and safe and all that good stuff. But we are inherently collaborative. And so when that starts happening, then the kinds of things you're raising will start automatically happening.
If I could just 30 seconds.
That's the short answer.
Yeah, 30-second response. Yes, beer, coffee, tea, I'll pay for all three. Number 2, adoption is a function of a wide variety of factors that don't necessarily always primarily prioritize quality. And I'll just
correct. I agree with you. I agree. But in the long term, what happens is that things that are crap tend to fall off. So again, not in the short term. I think when you look at longer term, people won't keep using crap. Well, unless they have utility from that crap that supersedes the quality measures. And if someone else has a better idea, it's all open forum.
To go to maybe Steve with a question.
Lots of Windows XP still in use. Love that comment, by the way, by Paul. Anyway.
Well, and I'm reminded of, when you're hiking in a place that has a bunch of use trails and you're trying to pick which way to go based upon which trail looks the most used. And it's always struck me that, trails that lead to dead ends get lots of use because people go out and then they come back, and somebody else goes out and then they come back. Yeah. And versus a trail that you only go one way on. And so we can get led astray by usage rates.
Yes. Agree.
You talked in passing about that people are free to join and that the Slack. There's Slack channels for the different projects and so forth.
Yeah. Maybe
you could post in chat sort of for everybody where that is and how that looks. And yeah, so my suggestion is that you just go and sign up for our newsletter, and all of that is in the newsletter. So go to agstack.org and sign up, and then the newsletter has all the pieces in it.
I will try to find the link here and post it. But if I don't find it in time, just sign up or send me a note or send Dorn something and we'll circulate something over.
Sounds good. And I mean, obviously, you're deeply involved in this, and I'm sure chasing new members and new work all day, every day. Who else, in terms of organizationally, is most active?
With me?
Sure. Yeah. I mean, you mentioned, I don't know, HP and IBM and some universities in passing. Who is the most kind of, where is the greatest commitment of time coming from?
Yeah. So we're in very early stages. I don't want people to, we're really at a vision stage. We've got a few products ready to go because I didn't want to have a blank shell. So we'll be launching something in alpha by the end of July on the weather server, for example, and some simple models. I even showed you some screenshots of that. But to answer your question, right now we have the kind of Linux Foundation backstop. So we have their staff, from their executive director to their, Todd Benzies, who's their coordinator, to their general counsel, and they're on many calls with us, with many of our, potential members, et cetera. But in fact, we have an ambassador program that we've started. We've actually invited OpenTEAMs to be an extension to help us collaborate with others. Dorn knows about that as well. But I'm actively, we're an open community. So if you guys know how this happens, if you want to help us with something, you just sort of raise your hand and then we just go down that path. I will say that it has been very gratifying to me how welcomed and substantively, quickly relative to my expectations, things have moved. It's always frustrating to not see more momentum, but I'm not in it for the short haul. And I know this will take time. This is a long view. And I think partners like the USDA, partners like CDFA in California, partners like the Indian government, partners like many others who we're talking with to advance this agenda are very excited about what we're doing. And we have good reach. We have convenings with them. And not to mention the 24 or so largest private companies in agriculture that are very interested in carbon. They're very interested in automation. They're very interested in, but those interest things take time to curate into a project, a funding grant, and then getting funding and using that funding to build an organization. So we're very lean. We got like 2 people. Nobody is getting paid anything. We're doing this as a, sweat and blood. And we will continue to do it until we either see no interest, which is not happening. It's the exact opposite. And that interest usually leads to more members with more resources, and we can just fill out. So it's an organic process at its very early stages. Did I answer your question, Steve?
Yeah. No, that's great. I was, yeah, perfect.
So I wonder if, sort of to follow on that a little bit, in terms of, you've talked a bunch about sort of the way the Linux Foundation works into sort of creating sustainable models for funding some of this commons infrastructure. I wonder if you might just go a little bit into some of that governance for this community and some of the different funding pathways that they, I mean, there's lots of different directions that these projects can go too.
Oh yeah, for sure. Yeah, so we've talked to 3-4 big stakeholder types. So large foundations are one type, government entities are another type, private companies are a third type, and then research institutions are the fourth type. And those are sort of funding institutions or funding types, if you will, right? So we've created a membership structure to fit that ecosystem stakeholders. But before I talk about that part, let me just sort of talk about governance, because I think that's one of the strengths of the Linux Foundation, and it's really important to sort of get that right. for moving forward. So I think the first thing is that it's a two-tier governance structure. There's a governing board that is essentially all the funding members. There are 3 tiers in our funding structure. The people who are funding the project get 1 board seat on the governing board. They can fund X or they can fund Y, but they only get 1 board seat. So that's to ensure that if somebody has a lot more money than somebody else, that within a very low limit, they can both have equal say on the governing board. And the governing board has really one, and I'm all new to this, by the way. This is the Linux Foundation's process, and usually Scott Nicholas, who's the general counsel, is the one who's explaining this. But on his behalf, and what my understanding is, I'll convey this, that generally speaking, this governing board is responsible for really just one key thing, and which is allocation of resources. So whatever we, approval or non-approval, essentially. So they help steer and prioritize the direction of what we do, what we develop. And by having both foundations who have more of a philanthropic and global reach with private sector, which has much more focused and product-centric view, you have a good diversity of, opinion and championship that with the structure, one doesn't dilute the other. And so essentially that is the governance structure that the Linux Foundation has used, tried and tested over 400 other organizations within the Linux Foundation alone with quite a bit of success. So Hyperledger, for example, is hundreds of millions of dollars of donations, moving fairly well. So there's lots of examples of that with big donors coming in of different types. So the second tier is actually the Technical Advisor Committee. And the Technical Advisory Committee is really chartered to lead topics of technical merit. So we have 11 topics. We have a TSE leader for each topic. They can be anybody. They could be AgStack staff. They could be non-members. They can be, usually they're nominated by either the governance committee or the staff. But it also is somebody who raises their hand and we look at their profile like, wow, we would love to have that. As an example of that, one of the things we're looking to do is create these polygon boundaries for the whole globe. So an automated creation of, field boundaries, not just US-wide, but, smaller across the globe. And there's some great work done at Stanford and some other universities. Dorn, you remember our conversation around that as well, that everybody's drawing these boundaries right now. And it's like, sharing boundaries and having some sort of geohashing framework for these boundaries could be very, very useful. So as an example of that, there's this group in Stanford wants to dock this project, and, we would take this project and kind of work within the TSE lead for that would be this professor at Stanford, because they've done 20 years of work. Now they're neither a member nor part of the staff. They raise their hand. It's an important topic. So we can get it. Right now it's Hewlett Packard, Ted Dunning is leading that topic, but most likely it'll be somebody from Stanford leading it. So I think that's the way these things organically happen. And the TSE has the ability to not choose the priority, but choose the design and convene the design. And the staff's responsibility is to ensure whatever comes out is up to, is secure, has high security, has good quality, is good, well documented, doesn't have any, sort of obvious problems for people to use at scale, whether they're smallholder farmers or large farmers or non-farmers. So I think we're more of the shepherding of the process. The TSE is more of the design team. This is a tech company. We're sort of the management. The TSE is the CTO organization, and then the board is like what a regular board would be. So I think that's kind of how it's structured. In terms of the actual funding mechanism, we have 6 tiers of membership. I'll start at the very top and go all the way to the bottom. the top tier, I'll see if I can remember all of them. And we had to have this many tiers to make sure we could accommodate all the different types of stakeholders. The top one is the partner tier. This is either a government or a very large foundation that wants to grant money in excess of $5 million per year for a minimum of 5 years. And this was actually requested by a few of the conversations we were having. The key caveat here is that there is a governance of one for that topic only. So other people can co-invest with them, but they're the single sole governance point for that particular topic that they want to fund. So that's a partner topic. Again, others can pool into that, but they would, let's say if the US government wanted to take that position, they would have a specific project, let's say around some topic, and they would say, look, we want to make sure that we're in the driver's seat, but we would like to make sure that PPP happened, public-private partnership, and we brought other people to sort of co-donate into that, and we can make a few calls, and other people would like to do so as well because it's being governed by the US government. So I think that's the partner level. The next level down is a sustaining level. Go ahead.
Sumer, I just wanted to recognize we're right at the top of the hour. So
okay.
I recommend, so we can, I think we've got that in a document.
Yeah, in a deck, we can circulate that.
Really appreciate that. And thank you all for joining us today. Laura, do you want to just close us out with a final comment as we head into the next in-depth? And but please join us in thanking Sumer.
Yeah, thank you, Sumer. That was a great presentation, and we're so excited about what you'll offer OpenTEAM in this community as well. We'll be back again in a couple weeks with another in-depth with Pablo Munoz-Ledo on look into data-driven storytelling, and hopefully you can join us then. So thanks.
Very nice to meet all of you. Thank you for the opportunity to present, and I hope you come join our community and help us build it. We're at the very beginnings. Thank you, everyone.
Thank you so much.
Thank you, Sumer. Bye-bye.